Hello, welcome to Nomis Academy. In today's video, we are going to be looking at Theorem 4 under Basic Geometric Theorems. Theorem 4. Okay, so Theorem 4 is under polygon and it states that the sum of the interior angles of any n-sided convex polygon is n minus 2 multiplied by 180 degrees. Alright, so this is the theorem. It says that the sum of the interior angles of any n-sided convex polygon is n minus 2 multiplied by 180. Now you would like to know the meaning of convex. Convex, when you say convex, the angle or the interior angle of a polygon which is less than 180 degrees is called a convex angle. Alright, now let's take this diagram. Okay, so we call here N P Q R. Okay, and then this is n-sided polygon. N-sided polygon. The reason why we didn't close the polygon, we can use this theorem to explain any of the polygon. Of course, you know the polygons. We have triangle, we have any of the quadrilateral, we have pentagon, we have hexagon, heptagon, octagon, and the rest. Alright, so we can use this theorem to prove any of those polygon I just mentioned. So now let's proceed with the proof. We need to prove this statement to know if this theorem is actually true and if we can also use this to solve problem under geometric theorems. Okay, now let's proceed. Given, what is given to us? We have a convex polygon which are N, P, Q, R. Okay, with n side. Now, this n side stands for any number of sides. For example, when you talk about a triangle has 3 sides, so meaning that n is equal to 3. And pentagon has 5 sides, so n is equal to 5. So we are working with an n-sided polygon. So let's go to the next proof. What we are going to prove. We are to prove that the angle at n plus the angle at q plus the angle at q plus the angle at r plus ellipses, meaning that we also have other angles for the n-sided polygon, alright, equal to n minus 2 multiplied by 180 degrees. So meaning that the interior angles, this angle plus this angle plus this angle plus this angle, and the other angles, since we cannot see, we don't actually know the particular angle and polygon we are working with. So let's continue with the proof. Construction. So we are going to join points N, P, Q, R, ellipses to the center O. So let's call this the center. So you are going to join N to O, P to O, and Q to O, R to O. So if we still have other angles, we just join them to O. Still talking about the same thing. All right, so let's proceed with the proof. So let's start with the proof. So you can see that we have triangles formed. As soon as we join NPQR together to O, triangles are formed. So triangle formed are triangles formed are triangle NOP, POQ, QOR, and ellipses up to, okay, we also need to write N triangles. So we have this. So now let's start picking them one by one. Sum of angles, let's use this symbol. Sum of angles in a triangle is equal to 180 degrees. We know this from the first theorem we explained. That's theorem 1. Now, sum of angles of the n triangles, that is the n triangles, that would be 180 multiplied by n. Okay, all right, so let me clean this other side. So we have, you remember the center, angle or sum of angles at point O, which is the center of the polygon, is 360 degrees. Okay, now you know, for us to get sum of angles of, or sum of the interior angles of the polygon, we write sum of angles, or sum of the interior angles of the n-sided polygon is equal to, now of course we are going to subtract this from the angle at the point. So that will be sum of angles of n triangles minus angles at point O. So to write this mathematically, we say sum of angles of the n-sided polygon equal to sum of angles of the n-sided. Remember, we say is what? 180 multiplied by n minus angles at the point, which is what? 360 degrees. Okay, so now what is common between these two? You can see that 180 is common, and then we have n minus 2. So 180 multiplied by n is 180 times n. 180 multiplied by minus 2, we have minus 360 degrees. So this is the proof to the statement. I repeat, it says that the sum of the interior angles of an n-sided convex polygon is 180 multiplied by n minus 2. So when you know the side, the number of sides of the polygon, you slot it in the formula. you will find the sum of the interior angles. Thank you for watching. See you next time. Bye.